In this video, I'm going to discuss how I added a chatbot interface to control a robot that I've built recently. The robot is built using the CamJam EduKit number 3 and a Raspberry Pi and some cloud services from Amazon Web Services. So you're looking at the architecture of how this additional capability works. To understand how I built this robot, please refer to my previous video on the subject in the same YouTube channel, or refer to my blog at awesomenow.com. So let's look at the architecture that describes this additional capability that I've added for the chatbot. The user converses with a chatbot that's powered by Amazon Lex. Amazon Lex is a service that helps understand the intent of a conversation based on text or speech input. Amazon Lex identifies the intent of the user, and based on that, it is able to trigger certain actions, which in this case are Lambda functions. So when a user converses using natural language, either texting or speaking to the chatbot, Amazon Lex can determine the intent. Now, in my scenario, the intent could be one of two. It could be an intent to move the robot in a certain direction, or to see an object and tell us what the object is using the object recognition services. So if the intent is to move, Lex actually calls an AWS Lambda function named moveRobot, which in turn talks to the AWS Internet of Things service and updates the device shadow for the robot, indicating that the robot should move. It also adds a direction such as move left, right, forward, or backward, based on what the user had stated during the interaction with the chatbot. There is also another Lambda function called cRobot. What cRobot does is that if the intent was to see an object or to look at an object that is placed in front of the robot, it actually updates the Lambda function actually updates the device shadow for the robot on AWS IoT, indicating that the robot should actually look for an object. Now, on the robot, there is a Python script that I've written. It basically subscribes to the AWS IoT shadow using an MQTT client, and when it finds that the shadow has been updated, it actually gets the update and executes or actions it. So if the update was to move left, for instance, it would actually move left. And if the IoT shadow was updated by the Lambda function to look at an object, it would actually pick that up and then run the code to actually look at an object, take a picture, upload it to Amazon S3, and then Amazon Recognition would actually look at that object or that image file and then determine what that object is, and then return that back to the robot, to the Python script, and then it would actually invoke the Amazon Poly service to convert that text to speech, and then the robot can actually speak. And you can say something like, I see a cup and I'm 99% sure, for instance. So that's basically how the robot works in a nutshell. It is the lower half of this design is exactly the same from the previous blog post where I explained how I've built the robot. The upper half is actually where the new capability of the chatbot has been added. And the new services that I've added include Amazon Lex and AWS IoT services and AWS Lambda. So these are the three new AWS services that I've added to get this additional capability so that I can control the robot using my own voice or using a text chat. So that's basically a good example on how you can use a chatbot to do very interesting things, such as move a robot or to look at objects as well. So let's proceed to a demo on how this thing works when put together.